looking at drowning.
Mm-hmm.
But, not the kind of stuff we see in the movies.
Right.
You sent over some really interesting material that suggests there's a lot more to it.
Yeah,
Like a
definitely.
whole hidden complexity beneath the surface. And that's what makes it so fascinating, right?
Yeah, it's way more nuanced
Yeah.
and honestly way more interesting than people realize.
I agree. I mean, for instance, this forensic pathology textbook that you sent over, it starts with a real attention grabber.
Okay.
It says, many corpses are recovered from water, but not all have drowned.
Hmm.
Kind of unsettling, right?
Yeah.
And then it goes on to say that even proving someone did drown can be really tricky.
Yeah, and I think that's something that people don't really consider. It kind of highlights how much we still don't know about how the human body reacts to water. It's not always, a straightforward equation.
No, not at all. It's like a detective story, right?
Right.
We think of drowning as pretty straightforward. Someone's in the water, they can't breathe, end of story. But you have to think about everything. Did they accidentally fall in? Did something happen before they ended up in the water?
Right.
I mean, the text even mentions natural deaths
Right.
occurring right before someone's found near water, which is crazy, right?
Yeah,
Just adds a whole other layer to this.
definitely. And then on top of that, you have to factor in decomposition, which is also influenced by the environment, right? Like cold water, for example, can really slow down that process.
Which means bodies can be recovered in surprisingly good condition even after weeks in the water, right?
Right. Exactly.
Which makes it even harder to figure out what happened.
Yeah, for sure.
And it made me think about all those classic signs of drowning that we always hear about, the froth at the mouth, water in the lungs.
Right. Right.
But the text suggests that those aren't always reliable.
Yeah, and that's where you get into the difference between like a dry drowning,
Right.
which is basically drowning without water-filled lungs, right?
Right.
Because essentially the body's spasms, like the final spasms, can actually sometimes prevent the water from even entering the lungs.
Oh, wow.
Or that water might be, absorbed into the bloodstream, so you don't see it in the lungs.
So someone could drown but not have those classic signs.
Yeah. Right, exactly. You wouldn't necessarily see it.
So you could have someone die in the water, and it looks like they drowned, but the actual cause of death is something totally different.
Exactly. And that's where those nuanced differences become really important, especially for, investigators who are trying to piece together what happened.
Right. And for anyone who loves a good mystery.
Right.
Speaking of, this next part really blew my mind. The text also talks about, get this, deaths from immersion other than drowning.
Okay.
So it's not even always about inhaling the water. Sometimes the shock of the cold water itself can be lethal.
Yeah, that's the cold shock reflex.
Right.
Where essentially like a sudden immersion, especially in really cold water,
Yeah.
it overloads the system and it can trigger an almost instantaneous cardiac arrest.
Yeah.
Like it's a powerful physiological response.
So what are the implications of this, like for researchers who are studying near drowning experiences, for example?
Well, it throws a wrench into a lot of the assumptions about how long a person might be conscious or able to react, right?
Right.
Because we assume there's a struggle. But with cold shock, it's potentially lights out right away, almost immediately.
It's terrifying.
Yeah.
And the text mentions that alcohol can actually amplify that response, which is a really,
Yeah.
sobering thought
Yeah.
for anyone who's, around water after a few drinks.
Right, exactly.
Then there's the laryngeal spasm.
Right.
The text seemed a little dubious about this one.
Yeah, so laryngeal spasm is this idea that like your throat could involuntarily clamp shut.
Right.
Almost like a protective reflex, right? To keep water out of your lungs.
Right.
The thing is, we're not entirely sure how big of a role that actually plays in, actual drowning deaths.
So it's a possibility, but maybe not the deciding factor.
Right, exactly.
But what about those diatoms?
Okay.
The text talked about them as these microscopic clues that could reveal if someone actually drowned or not.
Right. So diatoms, they're these microscopic algae. Right.
Well, yeah.
And they're found in water. And,
Yeah.
and the theory is that if you drown, you inhale water, obviously.
Right.
And those diatoms can get into your lungs.
Yeah.
And they can even, some of them can even cross over into like your bloodstream.
And if the heart is still pumping, they could travel to other parts of the body.
Exactly.
Like little breadcrumbs.
Yeah, like a little breadcrumb trail.
Oh, that's incredible.
Yeah, the idea is that they could act as these microscopic fingerprints, essentially.
Wow.
Placing someone at the scene, which would be, huge for forensic scientists, especially in cases where, a body's found way after death.
Right, right. But, sensing a
Exciting.
but coming.
Yeah.
The text mentions some pretty major flaws with this diadem test.
Yeah, unfortunately.
Yeah.
The biggest problem is diatoms aren't only in water.
Oh.
They're in the soil, they're in the air, they're even in some of the food we eat.
Oh, wow.
So finding them in a body doesn't automatically mean the person drowned. It could just mean they had, like, a plate of oysters recently or something.
So it's not exactly a slam dunk.
Right, like a lot of forensic techniques, it's a tool, right?
Right.
It needs to be interpreted in the bigger picture with all the other information.
And it seems like a good reminder that context is everything with these cases.
It really is.
Right.
Yeah.
We keep coming back to the fact that there are so many different reasons why someone might end up in the water, and not all of them point to drowning as the cause of death.
Exactly. We've
Yeah.
touched on, natural deaths, accidents, and then of course, the possibility of foul play.
Right.
And each of those, brings its own complexities to the investigation.
Let's unpack those a little bit. Take natural deaths, for instance. You mentioned that someone with a heart condition, let's say, could have a fatal episode while swimming,
Right.
which to someone who finds them, it would look like they drowned.
Right. And that's where those unreliable signs of drowning that we talked about earlier become even more important
Right.
because, you might see the water in the lungs, but it was the heart attack that actually caused the death.
So understanding like the nuances of those signs
Right.
and then interpreting them in light of maybe some pre-existing condition.
Exactly. Exactly.
Okay, so that's super important. What about accidents?
Well, imagine someone who slips and hits their head before falling into the water,
Okay.
right? So that head injury could knock them unconscious, and then the drowning is secondary.
So we're looking at a combination of factors, and it's up to the investigators to determine which was the primary cause, which was the result.
Exactly. And then you have, of course, like you said, the most, I guess, complicated scenario, which is foul play.
Right, because now you're introducing a whole other level of,
Exactly.
analysis. You're talking about potential evidence tampering, bodies being moved, all that stuff.
Exactly. And that's where a lot of these more advanced forensic techniques that we were talking about before come into play.
Right.
Analyzing the diatoms, even with, their limitations, might provide some clues.
Right.
Examining the body for any signs of a struggle, any injuries that don't quite line up with what you'd normally see with a typical drowning.
It's like piecing together a puzzle, but the pieces are scattered across two different landscapes. The world above the water and the world beneath it.
That's a really good analogy. And the more pieces you can find, the clearer the picture becomes, right?
Right.
Which is crucial for, bringing closure to families, and then if it's a crime, potentially bringing someone to justice.
Speaking of clarity, the text also mentioned using like genetic analysis in some drowning investigations,
Right.
which sounds really high tech. What's the thinking there?
It's a fascinating area of research, and it ties back to those natural deaths that we were talking about.
Okay.
Because scientists can now actually look at a person's DNA to see if there were any genetic predispositions to conditions that could cause, sudden death. So like, an undiagnosed heart problem or something like that.
So even if there's nothing like outwardly obvious, their own genes could hold the key to why they died in the water.
Exactly. Exactly. It's like having this whole other set of clues to analyze.
Yeah.
Hidden within, the very building blocks of our being.
Wow.
And it highlights how forensic science is always evolving,
Right.
always looking for new ways to understand the seemingly unexplainable.
It makes you realize how much goes into figuring out what happened in these cases. It's not just about the water, it's about the person, their history, their DNA.
And the context.
Yeah.
Always the context, right?
Right.
Every piece of information, every tiny little detail could be a vital clue.
Which I suppose is a good lesson for life in general.
It is.
Right. Paying attention, looking for the connections, understanding there's always more than meets the eye.
I think it's a really profound observation, honestly, because we often, we want simple answers.
Right.
But the truth is messy.
Right.
And it's way more nuanced, especially when you're dealing with something as complex as death.
So we've talked about diatoms, genetic analysis, the importance of context. Are there any other like tools in the forensic toolkit, so to speak?
Well, remember earlier when we were talking about the diatom test
Yeah?
and how, finding diatoms doesn't automatically mean drowning
Right.
because they're found in other places?
Right, right, right.
That's actually led to some new and exciting research
Yeah.
where instead of just looking for diatoms, scientists are looking at the possibility of using other microscopic organisms that are found in the body
Okay.
to figure out not just if someone drowned, but where.
Wait, so you're saying we could actually pinpoint the location of a drowning just by analyzing these tiny organisms?
It's possible, yeah.
Yeah,
It's still a developing area of research, but it's pretty amazing, right?
that's incredible.
Like, think about it. Every single body of water out there has, like, its own unique mix of microscopic life.
Right, right.
So if we can identify, the specific types of organisms in a body, it's almost like having a microscopic map
Wow.
pointing right back to, where the drowning happened.
So you're saying we could tell if someone drowned in like a lake versus the ocean,
Potentially, yeah.
or even like a specific part of the ocean.
That's the ultimate goal.
That feels like science fiction.
It does, doesn't it?
Mm.
But the science behind it is very real. Like I said, it's still early days,
Right.
but it has huge potential.
It really makes you wonder what other like hidden worlds are out there,
Exactly.
just waiting to be discovered as this research continues. Okay, so to bring it back to our deep dive today, it seems like the big takeaways are drowning is way more complicated than it looks. The classic signs aren't always reliable.
Right.
And the context surrounding the death, all those other factors are just as important as the actual physical evidence.
I think that's a great summary.
Oh, and of course, we have this whole microscopic world of potential clues just waiting to be explored.
Exactly. And that's what makes this field so fascinating.
It really is.
Yeah.
Well, there you have it. We've really gone deep on this one.
We did.
From dry drowning to diatoms to DNA analysis, we've covered a lot.
A lot of twists and turns.
And it just goes to show you, sometimes the truth really is beneath the surface. So until next time, keep asking those questions.
Absolutely.
Keep exploring those mysteries, and most importantly, stay curious.